A capacitor is a device that stores charge by virtue of two conductors, each connected to a different terminal of a battery or some other source of electric potential difference. The quantity that tells us how much charge we can store given a potential difference between these two conductors is called the capacitance. Here we will calculate the capacitance for a simple type of capacitor, which consists of two parallel plates, one connected to the positive terminal of the battery, the other connected to a negative terminal of the battery, and they are separated by a distance L. We will assume that the distance of separation is much smaller than the characteristic length of the sides of either plate, which means, to a good approximation, we may assume that these plates are infinite. We know that for an infinite plate carrying a uniformly distributed positive charge, the electric field it sets up is essentially constant and only depends on the charge density on the plate itself. Therefore, the positively charged plate will set up an electric field that is uniform, as is shown on the screen. On the outside, it will set up an electric field pointing in the opposite direction. The negatively charged plate will set up a similar electric field, but because it's a negatively charged plate, the electric field will point towards the plate itself. So in between the two plates, the contribution to the electric field from the negative plate is given by this expression. This means the total field between the two plates is just given by the sum of the contribution from the positive plate and that of the negative plate, as shown on the screen. We know that the surface charge density of each plate is just the amount of charge that it carries divided by the surface area itself. Therefore, we can simplify the electric field as is shown. We now want to know what the potential difference is between these two plates. In general, we know the potential difference is given by the path integral E dot ds, and that the potential difference is independent of the path we choose. So we choose the most convenient path. Here, this path is mapped out by the tiny little vectors ds and is everywhere antiparallel to the electric field. Therefore, everywhere on this path, E dot ds will be just the negative of the magnitude of the electric field times a tiny little length ds. To calculate the potential difference, we just integrate this expression. Because we know the electric field between these two charged plates will have a constant magnitude, we can take it outside of the integral, and we know that the integral of all the little, or the integral over ds, just means we have to add up all the little lengths ds until we get the distance of separation between these two plates. Therefore, the potential difference between the two plates, its absolute value can be written as is shown at the bottom of the screen, and the capacitance being defined as the amount of charge stored per unit potential difference then evaluates to this expression, which just depends on the area of the plates, the distance of separation, and a constant.